Okay, so today we're doing 13.3, the counting principle. There is an idea that I want you to know about this. So this is what it is. Go ahead and write this down for me. If one event can occur in m ways, and for each of these, a second event can occur in n ways, then the number of ways that the two events can occur together is m times n. So this is what we're going to be using for our entire lesson today. Go ahead and draw a red cloud around it. This is important. And then we'll kind of do, I think, 4 examples today that help you understand this concept. Okay, how many of you guys have ever run in a track meet before? Or done something in a track meet before? All right, so we've got more than half the class that's done track. How many of you have ever been to a track meet before? Okay, hands are down, especially if you've run, you've definitely been to one. So here's what this scenario is saying. At a track meet, there are 6 running events, there are 3 throwing events, and 2 relay events. So you as a person want to compete in 1 running event, 1 throwing event, and 1 relay event. We're trying to figure out how many different choices that you have that you could actually compete in. First of all, we want to kind of figure out how many running events did I say there were? 6 running events, okay? So I'm just going to kind of put a variable with it. 6 running events, we'll say you could run A or B or C, D, E, or F. Okay, so those are all the 6 running events that you could run. Now the next thing, throwing events. How many throwing events were there? 3 throwing events. All right, so these we could say could be G, H, and I. Those are all the events that you could run. Last thing, I said relay events. How many relay events are there? 2 relay events. So we'll have J and K. JK. All right, so there's 3 different options that you could do. So let's just figure out, if I said, hey, I'm just going to do A and G and J. That's one way that I could mix things up, all right? But I could also mix that up very differently. I could say we're going to do A and H and J. That's 2 different ways that I've just told you. Or we could come up with another one. We could say A, I, and J. So how many ways was that? We've talked about 3 ways now. Now we can start mixing it up a little bit differently. Instead, I could say, well, now I want to deal with B. So I could do B, G, and J. That's a 4th way. Do you see that there are tons of ways that I could mix these up, different events, different orders that you could do it in, okay? So there's an easier way than me sitting here and trying to color code how to combine these different events. Instead, let's read what we wrote for our notes at the very beginning that we put in a red cloud. Read that to me. If one event can occur in m ways, and for each of these a second event can occur in n ways, then the number of ways that the 2 events can occur together is m times n. So this is going to be much more simple than what I just was coming up with. How many different running events could I participate in? 6 of them. So I'm going to put 6 down because there are 6 ways that I could run. How many different ways could I go for a throwing event? 3. So I'm going to multiply it times 3 different ways for the throwing event. How many relay events did I say were possible? 2. And multiply that times 2. This is going to be a much more simple way than what I just was doing with color coding and marking. So what is 6 times 3 times 2? Okay, 36. Now, because it's a story problem, I need to have some kind of units attached. So go back to your question. It says if you want to compete in a running event, a throwing event, and a relay event, how many different choices do you have? So I have 36 different choices, or just 36 choices would be fine. All right, so all you have to do is you take the number of ways that you could mix things up and multiply it by the number of ways you could mix up the other things. And that's how you come up with m times n, or in this case we had 3 things and we just multiplied all 3 of those events together. Okay, let's do another example. This one is similar, but it's a little bit different also. For number 2, it says the standard Texas license plate has 3 letters followed by 4 digits. How many different license plates are possible if the digits and the letters can be repeated? All right, so who has a guess of what the answer is? Mason, what do you think?
12 license plates.
Okay, he thinks there's 12 different license plates. Who would agree with him? All right, I've got a couple people who agree. Does anyone disagree? Nobody disagrees. Okay, so you are telling me out of all the letters and numbers in the world that I could possibly put there, only 12 choices. Okay?
24.
Now 24 choices. How do you get 24?
If the letters can be repeated. I don't know. Well, there's 26 letters in the alphabet.
Okay, that's where we're going. There are 26 different letters in the alphabet. So let's look at this A right here. Listen, the A, how many options or how many ways? Because remember, we're choosing M ways. How many ways could that A be? How many choices? It could be 26 different choices. So I am going to put 26 choices for A. Times, how many choices do I have for B? Also 26, because I can repeat. How many different ways could I put in the C spot? I could also put 26 different ways in that spot. All right, so now we're moving on to the numbers. How many different numbers could go in that spot right there for the 1? Well, let's see what it says.
Pi.
I've got 4 digits. No, there's not an infinity amount that can go in that number 1 spot right there.
10. No.
I got 4. What do you think? What number could go there?
3.
1 through 9. Okay, so number 1, 2, 3, 4, 5, 6, 7, 8, or 9. How many of you would agree that 9 different numbers can go in that spot? There's actually one more number that could fit right there too. Also the number 0. So how many numbers could fit in that number 1 spot? 10 of them. So there are 10 different ways that we need to multiply. How many different ways can go in the number 2 spot? 10, because I'm allowed to repeat numbers. How many numbers can go in the number 3 spot? 10 different ways. And the number 4? 10. So there are actually going to be way more than only 12 different ways that I can put this in. I want you guys to put that in your calculator and find out how many different license plates we could come up with. All right, so yes, our 12 was way off, but what is the answer?
4,500,504.
Check your number again. It's not 4 million.
175,760,000.
Okay, so remember this right here says 1,000. This comma right here says million. So we've got 175,760,000. And what's my units?
License plates.
License plates.
I got that.
This is confusing.
All you have to do is find out the number of ways that that particular letter could be. For number 3, it says use the number of outcomes of the events to find the number of ways that the events can occur together. So this is not a difficult one. This is more simple, like you were thinking beforehand. There are simply 3 different ways that it could be on one, and there are 4 different ways or 4 different outcomes that it could be on another. So you've got to take M, which is 3 outcomes, and multiply it times N, which is 4 outcomes. So what's my answer going to be?
12 outcomes.
12 outcomes. How'd you figure that out? 3 times 4 equals 12 outcomes. Do the next one on your own. Okay, how do I find problem B?
6 times 3 times 12.
Okay, I know that we talked about M times N, but this could work for anything, however many ways. So it could be M times N times O. So you're just multiplying all the outcomes together. And when you do, how many outcomes do you get? 1,440 outcomes is correct. A bicycle lock consists of 4 numbers. Each number is a number from 0 to 12. How many lock combinations are possible? So what was the answer you guys thought?
52.
Okay, I heard 52. How do you get 52?
Well, because 0 is a number that you have to use, but if you put it in a calculator, it's automatically going to equal 0. So you got to add that to the 12, which makes that 13 kind of.
Okay, and then what did you do?
We did 4 times 13.
Okay, so you saw that there were 13 different number options and you multiplied it times 4 and you got 52 possible outcomes. How many of you would agree with that answer? Okay, more than half of you. Does anyone have a different answer you think it might be? What do you think, Mason?
The locker, like on the locker piece, doesn't it have 50 combinations or?
Nope, it says right here that it's only going to be from numbers 0 through 12. And there will be 4 different numbers. Okay, so here's what I want you to remember. What I said before is you're going to take the number of m ways, or the number of ways that it could occur, and multiply it by n ways, which is the number of ways the other one could occur. So let's just think for right now. There are going to be 4 numbers. So I've got number 1, 2, 3, and 4. All right, that's my 4 number options. How many different options or ways could happen in this blank? How many? If you know it's going to be from numbers 0 to 12, how many options are in there? How many ways can I put that number in? 13 different ways. Okay, so this number could be 13 ways. How about this one? That could also be 13. Remember, we're doing m times n. How many ways could this number be? 13 also, so we're going to multiply by another 13. And how many ways could this one be? Also 13. So should I have done 13 times 4? No, because there's not 4 ways. So this was not correct. So we have to do 13 times 13 times 13 times 13. If we do that, how many different combinations could it be? 28,561. And then don't forget to put your units next to it, which is? Combinations. All right, and that is the final problem today we're going to be doing with the counting principle. For tonight's homework, you've got just 8 problems, so go ahead and write down what this homework is.